Hello everyone. Today we are going to discuss about the origins of system engineering. Previously we have focused on the system engineering. What is system engineering? Its introduction. So in this next topic we are going to discuss about origins of system engineering. From where system engineering originated, since when system engineering is taking place in our system. So the outline of today's presentation is the origin of system engineering. So as we know, no particular date can be associated with the origin of system engineering. But system engineering principles have been practiced at some levels since the building of pyramids and maybe probably before. The recognition of system engineering as a different activity, distinct activity, is often associated with the effects of World War II. That is, especially in 1950s and 60s, after the World War, when a number of books were published that identified system engineering as a different discipline, as a distinct discipline, and afterwards it defined its place in engineering of the system. Uh, More generally, the recognition of system engineering as a unique activity evolved as a necessary corollary to the rapid growth of technology and its application to major military and commercial operations during the second half of the 20th century. The global conflagration of World War II provides a tremendous spur, a thing that encourages someone to the advancement of technology in order to gain a military advantage for one side to the other. So after the World War II, all of the countries, they want to go advance in the technology for the purpose to gain the military advantage over one to the other. So this effect of the World War provides a tremendous spur for the origin of system engineering. Next came the development of high performance aircraft, military radars, the proximity fuse, the German V1 and V2 missiles, and especially the atomic bomb required revolutionary advances in the application of energy, material, and information. All are the effects of World War II. These systems, which we have mentioned earlier, like aircraft, military radar, V1, V2 missiles, all these systems were complex, combining multiple technical disciplines, and their development posed engineering challenges significantly beyond that had been presented by their more conventional preceders. Moreover, the compressed development time schedules. Okay, the time schedule is also very of thin margin because as the country goes on advancement, so the need is to be the time schedule should be very much thin, very much compressed. So the compressed development time schedules imposed by wartime imperatives necessitated a level of organization and efficiency that require new approaches in program planning, technical coordination, and engineering management. Then, during the Cold War of 1950s, 60s, and 70s, military requirements continued to drive the growth of technology in jet propulsion, control system, and materials. So, after the World War, the Cold War started, and from 1950s, 60s, and 70s. So, in this era, the growth in technology in the field of jet propulsion, control system, and material. However, another development that of solid state electronics. So after this comes the solid state electronics development has had perhaps a more profound effect on technological growth. After the solid state electronics phase, comes the information age. So this is to a large extent made possible the still evolving information age, in which computing, network, and communication are extending the power and reach of the system far beyond their previous limits. So after the solid state electronics, the information age came, and which is also still evolving. Afterwards comes the digital computer age. Particularly significant in this connection is the development of digital computer and the associated software technology driving it, which increasingly is leading to the replacement of human control system by automation. Then computer control is qualitatively increasing the complexity of the system and is particularly important concern of the system engineering. So after the digital computer age and automation, then the computer control age, which is qualitatively increasing the complexity of the system. So if there is a complex system, but the use of computer also increases its complexity, and is particularly, and if the complexity increases, then it is a particular concern of system engineering.